1643, a guy named Isaac Newton was born. "43 years later, Isaac Newton presented his 3 laws of motion, which we all use in physics today. Newton's first law is that every object in motion will stay in motion, and every object at rest will remain at rest unless acted upon by an unbalanced force. Now, on Earth we have this thing called friction, and friction is the force resisting the movement of an object, so any object in motion with no constant force keeping it in motion will eventually come to rest due to friction. But in frictionless space, an object will keep traveling at a constant speed forever and ever because an object in motion will stay in motion unless acted upon by an unbalanced force. And now, another big component of Newton's first law is the law of inertia. Every mass possesses inertia, and inertia is an object's resistance to change. Now, an object with more mass will always have more inertia, and that is why an object that is heavier is harder to move. Now moving on to Newton's second law, the equation for Newton's second law is F net equals mass times acceleration. A good way to explain Newton's second law is using a free body diagram. On this one, the net force would be 250 because, as you can see, the F normal and F gravity cancels out, and the F friction cancels out 300 from the application force. Also, using the equation F net equals ma, we can see that mass is inversely proportional to the net force of an object, and because of that, more mass is needed to exert more force. Moving on to the last Newton's law, we will be talking about Newton's third law, which is that for every action there is an equal and opposite reaction, and the forces are of the same magnitude but opposite in direction. An important thing to remember is accelerations caused by action and reaction forces do not have to be equal. While the forces are equal in magnitude and opposite in direction, the accelerations of the objects are not necessarily equal in magnitude. In accord with Newton's second law of motion, F net equals ma, the acceleration of an object is dependent upon both force and mass. If the colliding objects have unequal mass, they will have unequal acceleration. So in this example, if the 5 kilogram box were to collide with the 1 million kilogram box, the 5 kilogram box would have a greater acceleration.